Welcome back. So today we're going to be working on our Angle Basics foldable. So we're going to start out with the handout I gave you that had Angle Basics on it. And if you have them as loose pieces of paper, if you notice there are some dashed lines on there, we're actually going to line up all of those dashed lines so then we can see some other pieces there. Sorry, so I got a dashed line there. So I'm just going to line those up right quick. And then once I have those lined up, then I'm just going to fold those over. So now I actually have my foldable and I can see all of my pieces. Alright, so I do have some definitions written into mine, so you may need to pause the video so you can get those written down. Okay, so the first one, as we fold that up, we're going to go to the top. So we have the definition of what is an angle. An angle is a set of points consisting of two different rays, and we talked about this a little bit with our constructions. We have two rays here with a common endpoint. We call that endpoint a vertex. Okay, so we have two rays, ray AC and ray AB. Our common vertex is A. We'll also sometimes call those rays sides. Okay, so then on this next piece here, more parts of our angle. We also have interiors and exteriors of our angles. So the interior, that just means the region that contains all the points between or inside the sides of our angle. So that's this whole piece in here. So all that is the interior. The exterior is just what it sounds like. It's everything that is outside of those sides. So that's going to be all of this stuff here. Anything that's on the outside of our sides or our rays, we call that the exterior of the angle. Okay? Alright, so our next piece is we're going to start naming some angles, just like we named rays and lines and things like that. We're going to name some angles. So when we look on here, we can name an angle in several different ways. So the first thing I want to make sure that you understand is the symbol. So if you look on all of these, I have this symbol out in front. Kind of looks like an L, a slanted over L. That's the angle symbol, and we have to use that every time. So the three different ways we can do it, we can start out first, we can use the vertex. So if there's only one angle that has that vertex, we can just use that letter. So we could say this is angle A. This is angle A. There's only one angle there, so I can use just the vertex. The other way is to use 3 points. We can use 1 point on each of the rays and the vertex. So this one would be either BAC or CAB, because we have to have that vertex in the middle. It's always that middle letter. You can kind of think about it as if you have your pencil down on the angle and you were to draw it, what letters would you pass through? What order would you pass through them? So this would be BAC, or if I start up here, CAB. The third way is to use a number. So if you notice here, I have a number 1 inside my angle. So I can call that angle 1. So those are the 3 different ways that we can name angles. So we're going to come down here, and I've got 3 different angles for us, and we're going to name those. We're going to name them in several different ways. So looking at number 1, the first way, we're going to use the vertex. Since there's only one angle here, we're going to call this angle Q. We're going to use the vertex. The second way that we could name it was with 3 letters. So let's do that. We're going to have angle. If I trace this, it would be RQP. So this is RQP. If I went the other direction, it would be angle PQR. And then the third way that we can name it is with a letter. I don't have any letters down here, so I can't do that with this one. Let's go over here to number 2. We're going to do the same thing. We're going to start by naming it with the vertex. There's only one angle here, so we're going to name this angle Y. The second way was to use those 3 letters again, so we're going to call this angle XYZ. We made sure we put our vertex in the center. We could also call that angle ZYX if we went in the reverse order. And then the third way to do that was with a number. This time we have a number there inside our angle, so we're going to call that angle 1. Okay, we've got one more of these that we're going to try. So on this next one, we're going to start out again, see if we can name it with our vertex. Again, we only have one angle here, so we are going to name that with the vertex. That's angle E. The second way was to use those 3 letters. So we're going to trace that and call it DEF. So that's angle DEF, or angle FED if we went in the reverse. The third way to do it was with a number. And again, we do have a number here inside of our angle, so we're going to call this angle 2. Angle 2. So that's how we name our angles. The next piece is we're going to look at a protractor postulate. So this is very similar to that ruler postulate that we just had with segments. So I do have that printed on your foldable for you. You can read through that if you would like. But I'm just going to kind of give you a summary of what's going on there with that protractor postulate. What that's saying is if I have this lined up here with 0, my 0 is on the bottom row of numbers. So I'm going to use that bottom row of numbers to come around here and measure this to 140 degrees. Now I don't always have it lined up with 0, so I can do the same thing that I did with that ruler postulate. I can subtract the values here, so I could have 140 minus 0 and take the absolute value, and that's going to give me the measurement of my angle there again. So I do have a picture down here on the bottom half of that piece, and we're actually going to go through and find some measurements. So we're going to find some measurements here. So the first one I want us to find is we're going to find the measure, that little m means measure, the measure of angle GHM. So if we look up here on our protractor, we've got it lined up. GH is here at 0. 0 is the top row of numbers. So we're going to continue with those until we get to M. So we come up here, that's 30, and we're going to go a little bit further. It's about halfway, so that looks like that's 35. And if you actually have a protractor, it's a little easier to see how many actual little hash marks are in there. But that looks pretty close to 35. Let's do another one here. So let's take one, let's go MHL. So the measure of angle MHL. Well, if you notice here, M does not start on 0. We said that started on 35. So we're going to take that 35. We're going to find where L hits. That hits at 90. And remember, I said it's similar to our ruler postulate because we can take the difference between those two numbers and find the absolute value of that, and that's going to give us the measure of that angle. So 90 minus 35. So 90 minus 30 would be 60, and take more away, that's 55 degrees. Okay? All right, so let's keep moving. Now we're going to go on to some types of angles. So we have our first two types. We have acute and we have right. So this one we have an acute angle. And the measure is greater than 0 and less than 90 degrees. So any angle that measures more than 0 but less than 90, we're going to call that an acute. Okay, the second one that we have is this right angle. So anytime we have one that measures exactly 90 degrees, we're going to call that a right angle. Okay? So we're actually going to come down here to this bottom piece, and we're going to find some acute and some right angles. Okay, so on the acute side, over here on the left, we're going to name some acute angles. So let's go angle. We need to find something that's less than 90. Well, 90 is straight up and down if I start over here at 0. So this one, GHM, that's less than 90. So GHM. If I come over here to the right, I start out here at 0 again. I can come up to K, and that's still less than 90, so we can say angle JHK would also be an acute angle. We know from the last one we found MHL to be 55 degrees. That's greater than 0 but less than 90, so we can say angle MHL. And if we look over here at LHK, we've got from 90 to 125. That's going to be less than 90 degrees as well. So angle LHK would also be acute. Okay? And I'm going to ask you to measure each one of those. So on your foldable, I want you to actually have some measurements in there. We said that this MHL was 55 degrees, so I'm going to go ahead and put that one in there. GHM, we said that one was 35, so I'm going to go ahead and put that one in there. And I want you to fill in these other two, so make sure that you have those other measurements filled in there. Okay, so then let's go over here to our right angle. We need to find an angle that's exactly 90 degrees. So if I look up here, I've got angle GHL. So if you notice, it starts at 0 and goes straight up to 90. So that's going to be a right angle. We can also start over here at J, come over to H and straight up, and that's going to be 90 as well. So JHL. Are there any others though? Well, let's look here at this one. This MHK. I'm not sure, so I'm going to check that one. MHK. So let's use that protractor postulate that we just talked about. We said MH was at 35. We can see HK is at 125. So we're going to subtract those and find the absolute value, and that does come out to 90 degrees. So that is a right angle. So this MHK is also a right angle. So I think that's all the right angles that we have. So let's go on to the next page. Now we have our obtuse and our straight angles. So we have an obtuse over here on the left. That's the measure is always going to be greater than 90, but less than 180. Okay, so greater than 90, less than 180, we call that an obtuse angle. Then I'm going to come over here to the top one on the right, a straight. And a straight angle means that it measures exactly 180 degrees. Not 181, not 179, exactly 180. And then I added this extra one on here because I always have students that ask, well, what if it's more than 180? What if it is 181? What is that? That's called a reflex angle. So any angle that measures greater than 180 but less than 360, we call that a reflex angle. Because if it goes all the way around 360 degrees, that's a circle. Okay? So we're making a circle there. So if it's actually 360 degrees, it's just going to end up being a ray because it's going to be on top of itself again. So we're going to do some examples with our obtuse and straight down here. So we have that same picture that we've been working with. So for an obtuse angle, let's try to find some obtuse angles. We want something that's greater than 90 but less than 180. So let's start over here at G again. If I go from G to H, we said straight up was 90, so I want something that's more to the right. That would be my K. So angle GHK, that would be an obtuse angle. I can do the same thing starting over here with J. That's my 0. I don't want to go straight up because that's 90. I want to go a little bit more to the left. So that's going to be M. So JHM. So angle JHM. Those are going to be my obtuse angles. So then the last one is to find some straight angles. So remember we said a straight angle is exactly 180 degrees. So if I start here at 0, and I go all the way around to 180, I'm over here at J. So that's going to be angle GHJ, because remember our vertex has to be in the middle. We could also have called this angle JHG. And the same thing with these others. We could have called these the opposite also. And I'm going to have you do a little bit more homework here. I'm going to have you find the exact measurement of each of those obtuse angles. We'll do one of them together. This GHK from 0, we're going all the way around, and that's at 125 degrees. You can find that second one for me. Have that filled out on your foldable. Okay, we're going to pause right there for 1 second, and I'm going to get out my doodle notes. Okay, so here's my doodle notes with my angle addition postulate on it. And so for this one, it's very similar to that segment addition postulate that we talked about. So if B is the interior of angle AOC, then if we add together those two angles, AOB and BOC, then we're going to get the measure of the bigger angle, which was our angle AOC. Okay, so if we drew a picture of that, if we have angle A, this is O, and C is over here, and B is somewhere in the middle, if I add together this angle and this angle, that's going to give me the measure of my big angle. Okay, so let's look at a couple examples up here right quick. So if you look up here, this one tells us that the two adjacent angles that form a peak for a roof in a howe truss measure 60 degrees. So that means this little angle is 60 degrees and this little angle is 60 degrees. Okay, so if I add those together, 60 degrees plus 60 degrees, I'm going to get the measure of the peak, which is this big angle LMN, which is the measure of angle LMN, and we know that's 120 degrees then. So angle LMN is 120 degrees. Down here we have a Fink truss, and it says that each top angle of a Fink truss is congruent. So all these congruent means that they're all the exact same size. And the total is 120 degrees. So I have three angles. I don't know what measure those are, so I'm going to put an X there. 3x equals a total of 120 degrees. So how much is each one of those angles? I'm going to divide by 3 on both sides, so I get x equals 40 degrees. So each one of those angles is 40 degrees. 40 degrees in there. All right, so a couple things that I want you to do is you are going to define a postulate. We talked about this in class the other day, so define that postulate for me, and then I want you to finish filling out this bottom piece. I apologize for going over a little bit here on our video, but you guys have a couple of days to do this, so hopefully it doesn't cause you too much trouble. Have a great evening. I'll see you in class. Bye.